Hey everyone, I want to give a heartfelt thanks. It took a long time to reach 1,000 subscribers, and 3 weeks ago I reached that point, and I wanted to thank everyone. And now 3 weeks later, I'm at just over 2,000 subscribers. I cannot tell you how much that means to me, how much I appreciate it. I have got so much going on. I'm trying to play catch up from all the parts delays in the past couple months. I'm going to have this cold pizza, the breakfast of champions. And then I'm going to get to this orange Rocker 32 with no sound. So, priorities. And then you'll get to see this orange. But I wanted to take the time to say thank you. Thank you so much. All right, pizza properly dispatched. Now I've got this orange Rocker 32. I've not had one of these in before. Essentially, it's two AC15s. So you've got a preamp, which is all mono, and then it splits to two different outputs with two different output transformers. Each output has got a pair of EL84s. And the complaint the owner has, the amp's kind of silent on the issue, is that the amp is silent on every issue. There's no output. So I don't have a schematic for this. Never worked on one before. I'm just going to go and measure voltages and see if I find a place where the voltages are not what I would expect. So let me start with these EL84s on this side. Okay, I have no high DC seemingly on pin 7, which would be the plate. I've got no DC present at pin 9, which would be the screen. Now that's measuring between these pins and the chassis ground. That does not mean that this is going to be actual ground in the amp. So let me see if I can do some continuity checks to see if there's a distinction between the chassis ground and actual ground in this amp. And the easiest place to do that would be here. That's this point on the board. And that board shows continuity to chassis, so I should be able to measure chassis at any point and find DC voltage. Let me do that at pin 6 of this preamp tube. Now, all right, so let me pause this and see if the fuse, which is right here, which is the HT fuse, is blown. Indeed, it was blown. It's a 500 milliamp slow blow fuse. I put a new one in, powering that back up with it in standby. Now, there are several reasons an HT fuse might blow. There could be a fault in one of the tubes, typically a power tube. It could be a fault in one of the filter capacitors in one of the preamp nodes, causing too much current to flow, tripping the fuse. Or it could be that an owner operated the amp with one of the speakers disconnected or one of the speakers failed. So I've got one output going to a speaker and the other output going to a dummy load. And I'm taking out a standby. I've got a current limiter on to see if there's any condition that would cause a fuse to blow. Now that does not necessarily mean that this HT fuse will not blow again, but let's find out. Oh yeah, it's glowing real bright. Turn that off. So at this point, we probably have, the most likely cause is a bad output tube. Let me pause this and I'll show you why that's a bit of a pain. They have the output tubes in this amp in these stupid cages. They have these cages, and they also have tube retainers. So this might look pretty on the internet. This is in a combo, where these tubes aren't going to be subjected to anything bumping up against them anyway. These cages are dumb. These cages need to go away. And I'm going to get out my screwdriver and make that happen. And I'm going to pause this so you don't have to watch the laborious process of pulling cages off. All right, here's the last one. Each cage has 8 half-inch or equivalent metric length half-inch screws. They could have used 1/4 inch or less. These are overkill in terms of the screws, and because of the cage height, I didn't feel like going out and finding the right extension for my power tool, so I do all that by hand. Good luck ever changing one of these tubes on a gig with these things. Now they have fairly good implementation of tube retainers here. They have the springs, but they have these nice, it looks like a Teflon or other similar high temperature rubber material on them. So the springs are not going to break the glass. So that's nice. And get all the output tubes out and inspect the labels for heat. Yep, that one's been running really hot. These are JJs. That does not mean there's anything wrong with JJ EL84s. But many app designs, that one's faded as well, severely punish EL84s. If it's a cathode bias amp, they often bias them way too hot with no screen grid protection. If it's a fixed bias amp, like the Blues Junior, they often have a non-adjustable fixed bias, which also biases the tubes way too hot, often also with inadequate screen grid protection. All right, so now with the output tubes out, let's repeat that test and see if we're still drawing too much current. If I didn't have that current limiter in line with everything, those tubes would have, if it is the tubes, if I didn't have that current limiter, I just would have blown the HT fuse all over again. So this would have been a very difficult thing for the average guitarist to troubleshoot, even if the average guitarist knew that it was output tubes. It would be difficult to do because they make it impossible to access the tubes. Take it out of standby. No current draw. Let's see what the DC voltages present are. And then I will find out if this is fixed or cathode bias. I assume it's fixed. I see a little trim pot there. Now that says hum balance. I only see the one trim pot in here. So this may be cathode biased. I will find out. So let's take some DC measurements now with no tubes present. The plate voltage is 347.6. The screen is 345. That's all to be expected. We put in a test pair of EL84s here and here. And that will tell us if it was just bad tubes from the as the amp came in, or whether there's a faulty component on one side or the other. It'll trace it down to this pair of sockets or that pair of sockets. So let's put in a new pair of EL84s on one side. This is a quad of Mullards that I use as a test bed for the AC30s that I do. So these are my shop tubes, which are quite good. And they can handle too hot a bias for a short period. So let me turn the amp on in standby. Let these warm up. Take it out of standby and see what the current is. I suspect that those JJs have just failed. Again, nothing wrong with the JJs. I've used them a lot successfully. But I suspect that the operating conditions in this amp are going to be contributing to tube failure. Out of standby, full power. Okay. There is no big current draw. Let's see if we have signal. There's no hiss or anything coming out of the amp, but they may have a mute circuit. This is odd. We have DC voltage present. but we have no signal. Let me power it back off and make sure there's no problem with anything in these sockets. That'll tell us part of it. The next issue is whether one of these other tubes has failed or if there's a multi-layered problem here. I'll take these out. I did not see anything on the circuit board that would point to some complicated circuit that would require both sides to be fully operational. Oh, I know what I did. Duh. Okay. I'm leaving this in just as proof that everyone makes mistakes. Remember I said I had one side of the output connected to a speaker, the other side connected to a dummy load. Well, I was just trying to listen to the dummy load side. Okay. Sorry, cold pizza sometimes slows the brain. Let's say that. I'm going to take it out of standby. No major current draw. Let's see if we have sound now that we're actually listening to the side that has a speaker connection. Okay, so this amp is healthy, most likely. Next test is to put EL84s on this side as well, just to make sure that it's not some current limitation in the amp, which is not being tripped by a pair of EL84s, but would be tripped by all four. I suspect that one or more of those JJs just gave up the ghost. So let's see what the current draw is like now, and I will test each side of the output for sound. So power it on, pick up the guitar. I have signal generators. I use them when appropriate. This is a relatively new amp with a relatively minor problem. A guitar is both the quickest and in some ways the most informative signal generator there is. Did I go the right way? It went half power. All right, full power is on and no huge current draw. Back to standby. Flip which side of the output has the speaker versus the dummy load. Should sound the same. All right, that's good. Let's turn the master all the way down for the next part of our test. You know, on the surface level, if I were to stop right now and put on the ticket, no output caused by blown HT fuse blown by JJ EL84s, new output tubes and HT fuse installed, amp works fine, and sent it back. You know, most people would say, great, good job. I don't think that is the full story. So I want to put this on in standby again. I'm going to take a measurement at the grid of the EL84s. I think there's a bias issue which is causing the problems. Now I see each side here has got a 150 ohm resistor, 7 watt. I'm going to assume, in this case, I don't think any asses are being made of anyone, that this is the cathode resistor on each pair of output tubes. There's another one over here. And 150 ohms is a fairly common place to have EL84s on when they're cathode biased. And they've got 1K 5 watt screen grids. So that tells me good things. I'm assuming this is cathode bias. So I should have no DC voltage present at pin 2. And indeed I have 0. And I should have a positive voltage 10 to 13 volts probably on pin 3, which is the cathode. I gotta take it off standby for that to happen, sorry. The grid voltage would have been the same. 9.61. Now I've got a current limiter, so all the voltages will be a little bit low. We measure the grid on both, just in case another cause of a blown tube can be DC present at the grid. That has none. That has none. That has none. So I don't think we have any leaky caps leaking DC onto the grid. So the next thing to do is power it off. Take off my current limiter because I'm pretty sure that these tubes are going to be fine. And I'm going to check where this cathode bias out is actually cathode biasing each output section. An EL84 is nominally a 12 watt tube. And when it's cathode biased, you really want to be about 100 to 115% idle dissipation. So roughly 12 to 14 watts is the desired range. Hotter than 14 watts, the tubes die, as these have died. Lower than 12 watts, you begin to have a bit of a graininess when you really push them up because of oddities of cathode bias that I'm not going to get into, and how the current actually, the gain actually works. Sorry to be a little bit distracted. So first thing I'm going to do is measure the cathode resistor value, what it actually is. It says 150 ohms on each one. And the one over here is, can't see it, let me move the setup. This one here is hidden underneath the output jack board, but I don't need to measure at the physical resistor. I can measure from pin 3 to ground on each side. So one of them, this left pair, 148.8 ohms. I'll write that down in my calculator. The other one is 148.7 ohms. So they're very closely matched, that's good. Now I power the amp up without the current limiter, and I'll measure the voltage across the cathode resistor, and then I'll measure the voltage from plate to cathode on each tube. So let me start with the cathode. Watch it come back up to almost 10 volts. It'll probably be a little bit over 10 volts now that the current limiter's off. As the tubes warm up, it'll stabilize. Got 120 volts coming out of the walls right now. 11.75 is about where it stabilizes. I'll check that again after a while. Let's see about on this side. 11.8. Actually, they've both stabilized to 11.85. That's good. All right, so 11.85. Now I'll measure the voltage. I can either measure the voltage from plate to ground and subtract the voltage from cathode to ground. It's easier just to measure the voltage from plate to cathode. A little bit less math. 307.5. .1. That might just be fluctuation in the wall. Let me put that in there. in my calculator. Which tells me that each tube is idling at 12.24 watts, which means that this amp is not biased too hot, and each one of them has more than adequate screen grid protection with those 1K screen grids. So there is nothing intrinsic to this amp which should be causing those tubes to prematurely die. I don't know how old this amp is. I don't know if the amp has been dropped, hit potholes. From everything that I measure here, it seems like a good operating condition for these tubes. Now this is in a combo. It's possible that this thing has been pushed up against a wall running at full tilt with very little airflow. So I'll talk to the owner about that and see if I can have his permission to leave these stupid cages off, because they do no one any good. They just look cool in a photo of the amp if you're considering buying it. It looks like overkill because it is. While I have the amp set like this, well, I have to do this again once I put in the final tubes. Here's that hum balance pot. And the effect is subtle. Let me turn the master volume all the way up. This amp does, in fact, have a mute, so that if nothing is plugged into the input jack, the input to the phase inverter is muted. So let me plug in with a guitar with its volume on 0. And see what the hum sounds like. All right, that works. So, this amp is seeming pretty healthy, but on each side, a pair of EL84s, you can see that discoloration where it started off red and has gone to that pale gray, has just been running too hot. These are toast. He needs new output tubes. But I had to make sure that there was no condition that I found that was causing that. And I don't mean to cast any aspersions on Orange, but there are an awful lot of factory amps that absolutely roast their EL84s, the Blues Juniors, the Classic 30s, the Classic 50s, many, many, many others. From what I can tell, this amp is really well designed, really well built at its price point. It's got a through-hole plated, double-sided, relatively thick PCB. It's got the standard alpha pots everyone uses. Great big knobs on the other side, tiny little actual pots. But you know, this is so much better built than so many other things in this price point. And it's a pretty good sounding amp. I think the two output sections, two output transformers, is kind of a gimmick. It would make more sense if it was stereo. It does have a stereo effects loop, so you could use stereo effects and get some more out of this. But at the same time, it's going to a combo, so that the two speakers are only going to be a few inches away from each other. You're not going to get much stereo spread. Anyway, I digress. I'm going to call the owner, let him know that he needs a new matched quad of EL84s, and that I've changed the HT fuse, and I can let him know that I have gone through and made sure that this next quad of EL84s are very unlikely to just start burning from the get-go. So we'll see how this goes.